Lab 2. So the purpose of this lab was to further extend Lab 1, where we determined the excess charge on a tape and further familiarize ourselves with the fundamental principles of electricity. Here we mainly focus on visualizing this in Glow script and changing it from a point charge to a line of charges. So a brief overview of what we did experimentally. So we used Coulomb's law and the electric field equation along with their relation and um, and Newton's third law. The experiment we conducted. So first we created a base tape and put an upper tape on it and ripped the upper tape to create a charged tape. We used our hands, which are a neutral object, to test whether the tape was attracted to our hand. If the tape was attracted, then that means the tape was successfully charged. We then tried to float one charged tape above another charged tape. So, some assumptions we made in these calculations. We assumed there was no momentum, that it was at equilibrium, the system was at equilibrium, the upper tape, and there's no net force, it's zero. The net force is equal to zero, allowing us to use Newton's third law, where Fe equals Fg in our equation to find the charge on the tape. Here we use the length of the tape, which is 0.2 meters, times the length per gram of tape to find the gravitational force, which is underlined in red. And then using that, we were able to find Q. This Q is important, and that Q squared, because we assume that the charges on both tape is equal, that they're evenly distributed, and we also treated these tapes like a point charge. And find the excess charge on a tape, we had to assume that the area of an atom would take up the whole area, using the length dimension of the atom to find the area. Then we took the area of the tape and the amount of atoms that should be in that area and divided by total amount of atoms to find the number of atoms on the surface, and then find the excess electrons, the number, our charge that we calculated earlier, over charge per electron, and then the percent of excess charge. Here is the important values that we collected: the charge, the force of gravity, electric force, and excess charge. Here's the code, the main part of this lab. First, we had to create an electric field equation in this code and also create a line of charges. Here is the most important part, the creation of finding the electric field, electric force here, and creating the arrows that we will soon see. So these arrows were scaled so that we could see all these arrows. The gravitational force arrow is extremely small, but it's right at the bottom of the blue line of charges. Anyway, so from the calculated values earlier to this program values, we found a percent difference of 199 for the electric force and 0.01 for the force of gravity. This error could be due to me finding these values at home because I was sick, and overhandling of the tape. There may have also been a programming error which led to the electric force being greater than expected. So for YF and Y, to compare the point charge and line values, there was a percent difference of 1.7, Why do these estimates differ? Well, when we assume it's a point charge, it's that charge centralized working on the point of observation. While if it's a line of charges, it's many charges working on that observation point from different angles, which might cause it to be less and doesn't allow each charge to feel the observation point to feel the full effect of every charge because it's at an angle.